So here are the formulas for the metabolic calculations. You will receive this chart on the test, so you don't need to actually memorize this chart. We'll walk through this and explain what is going on with each of these components. But there are going to be other conversions that you're going to have to know. So they'll give you these formulas, but you will have to know other conversion factors by memory. So always when you're looking at the total energy expenditure, so if you look at the very top under the title, it says the sum of the resting plus the horizontal plus the vertical or resistance components. Okay, so what does that mean? It's like, all right, for each activity, there's always a resting component. If you remember, your resting oxygen consumption is 1 met or 3.5 milliliters per kilogram per minute. Milliliters of oxygen per kilogram per minute. So again, you need to be able to know 1 met is 3.5 milliliters per kilogram per minute. So that is the resting component. So that's added into every equation. The horizontal component, that is your resistance as you travel across a horizontal surface. So the amount of frictional component, the amount of energy that it takes to overcome that. So there's a constant number times your speed, and we'll talk about converting your speed to meters per minute. And then the vertical component or the resistance component is if you're walking or running, it's your flight. How much does it take your body to travel through space? And if it's resistance, it is the amount of your body mass or your step rate for stepping. So body mass for cycling or step rate for stepping. And then you see the accuracy there. We just talked about that on the previous slide. So whenever you are looking at doing the equations, there's always horizontal, vertical, and resting component to give you your total energy expenditure. If you look at the bottom of the table, they talk about kilogram meters per minute, how to convert pounds to kilograms, inches to centimeters. Or you could divide by 2.2 to get from pounds to kilograms. Meters per minute, 26.8 miles per hour to meters per minute. So all of those you are going to have to know. And body weight is always in kilograms. Okay. So as I mentioned, you're not going to receive those conversions. You're going to get the formulas only. And at the certification center, they're going to give you a calculator on screen and some sort of dry erase board for your scratch paper for you to do the calculations. Same thing would be true if you're doing the body composition calculations. They'll give you the calculator and the formulas that you will need at that time. So you can't bring those in. So as I mentioned, you need to feel very comfortable with conversions and units of energy. Can you go from METs to VO2 in milliliters per kilogram per minute? How do you get to liters per minute? If you're having trouble with that type of dimensional analysis, you want to be sure that you practice that. We'll have a worksheet that does that. So to have success with equations, you always want to be sure you've got the appropriate units. Make sure everything is metric. So weight is in kilograms. Flywheel force is in kps or kilograms. A kilopond is the same as a kilogram. Speed needs to be converted from miles per hour to meters per minute. Transform your VO2 to what you need. It's all expressions of energy. METs to milliliters per kilograms per minute, or vice versa. Then working to liters per minute, and then working to kilocalories. I always find I have to write down the equation. Horizontal equals this, vertical equals this, and resting equals this, just to make sure I've got all the components that I need to calculate my VO2. So writing it down just takes a couple extra seconds, and then you're able to work through it a little bit more easily.